again, I want to do one more problem. Here we're going to rotate around the specified axis. This one goes around a y equals 1. So let's take a look at this. One real quick note here. If we look at it, this should say x equals the y squared minus 3, or y minus 3 squared. So I'm looking at the curves. X equals y minus 3 squared, x equals 4, and I'm going around the y equals 1 axis. I'm going to sketch at least the axis real quick here. I don't always do this first, but sometimes it's helpful. So this is my x-axis, my y-axis. If I look at y equals 1, and I'll put it, or let's go up to 5, 2, 3, 4, and 5. Here's 5. And we'll go down to negative 4, just so we have some numbers on there. And let's go 1, 2, oops, it's not really even, 2, 3, and 4. We'll make this a 5, and I'll just put a negative 1 over here. All right, so what we have is for y equals 1 is I'm looking at this line right here. I really don't like that one, it's in the wrong place. All right, so this is y equals 1 right there, and this is what I'm rotating around. So to start with, I'm looking at this and thinking about which method I want to use. And what I notice is that this right here is one of those sideways parabolas. Okay, so it's going to open to the positive infinity side when I actually FOIL the y minus 3 squared. I'm going to get a y squared. It's positive. It opens toward positive infinity. So what I'm going to do is I'm going to say, well, since I'm looking at a parabola and I don't know how I could solve that, this is going to turn into, if I wanted to, it would turn into a y squared minus a 6y plus a 9, and I wouldn't be able to solve that for y very easily. So I really don't want an a of x, right? Because I don't want to have to find a y equals something. So I prefer to have an a of y. That means I want to cut through the y-axis. And so if I think about shells, so if I would just draw a shell, just a real quick shell here, and imagine the cookie cutter going through an axis, it's going to go through the y-axis. So I want to use cylindrical shells. So that's my first comment here. I want to use cylindrical shells. And sometimes I call those shells and sometimes I call them cylinders. And that's because I really want v to equal the integral from c to d of a of y dy, all right? And that gives that to me because I'm going to cut through the y-axis here, all right? So I'm going to use cylinders, cylindrical shells, to do this problem. And so I'm looking for an a of y, my area in terms of y. So let's take a look at the graph real quick. If I'm looking at my points of intersection, so I'm just going to write POI, points of intersection, all right? I'm going to set my x equal to my x. So I'm going to get a y minus 3 all squared is equal to 4. That's setting each of these two terms equal to each other, right? These two equations we were given. That means if I square root both sides, remember when I square root on this side over here, I need to take the positive and negative of it. So I'm going to have a y minus 3 is equal to a plus or minus 2. So I'm going to split it kind of into 2. I've got a y minus 3 is equal to a positive 2. That's going to give me a y equal to 5. So I'm going to have a point at, remember my x value here was 4. So at 4, 5. Okay. My second one, I get y minus 3 is equal to negative 2. I'm going to get a y equal to 1. I'm going to have a point at 4, 1. Okay, so those give me 2 points for my graph. So let's go ahead and pop those on there. I have one at 4, 5. So I have one way up here. And I have one at 4, 1. It's right here. I do have that x equals 4 line right about here. Okay, so this is x equal to 4. If I think about my parabola, I'm going to find one more point at x equals, let's go in the middle, so how about 3? At x equals 3, I get Actually, let's do it at y equals 3. Let's pick the right direction. At y equals 3, I'm splitting right between the 1 and the 5. At y equals 3, I get an x that's equal to a y minus 3 squared. So that's going to be equal to a 3 minus 3 squared. So I get a 0. So I'm going to get a 0, 3 point there. And that's going to tell me actually what my vertex is there. All right, so I have another point right here, that's 0, 3, and I can kind of see my sideways parabola there. All right, so this right here, this is what I'm rotating. All right, and I'm rotating that around that y equals 1 axis. Let's go ahead and draw the other half of it so you can see the other half of it. I would have that same point right here. I would have a point that's down 2 on the x-axis, so at negative 1. And then I have a point that's 4 away, 1, 2, 3, and 4, so I'm at negative 3, right about here. I have something that comes down like so, and then like that. Okay, a little lopsided, but you get the idea. All right. Looks to me like a bundt cake where the middle grew together. All right, I know you love my food analogies. So let's draw our representative cylinder. I'm going to draw one right here. I'll put it right here. Let's draw this. All right, so let's take a look at the cylinder pulled out. And I have, here's my sideways cylinder. And I like to draw them sideways just because it's the same orientation. What I'm looking for first is my radius. So I'm looking for what this is right from here to here, right? And remember that's going to change. So let's take a look. If I pull way out here, I'm looking at this total distance right here. That's equal to y, whatever the height is that I am above the x-axis there, right? And then if I look at the distance from here to here, it's equal to 1, right? Perfect. And that means that the distance from here to here must be y minus 1. Make sense? So if this covers the whole distance to wherever my shell is, I know the distance from here to here is 1, and the distance from here to here must be y minus 1, and that's going to be my radius. All right, so I'm going to say r equals y minus 1. And then my height, that's going to be from here over to here. So here we're looking for in terms of y, right? Because I'm looking for, I'm looking for this a of y, right? So my height is going to be my right curve, since I'm sideways, minus my left, okay? So my right curve is going to be the x equals 4, and my left curve, that x value, is at y minus 3 squared. All right, so that's going to be my height. I'm going to clean that up a little bit. I'm going to change colors though. So h is going to be 4 minus, this quantity is all enclosed, oy squared minus 6y plus a 9. And so if I distribute, I'm going to get a negative y squared plus a 6y. I'll have 4 minus 9, so I'll get a minus a 5. All right? Okay, so area. Let's put a little blue there. We have a line to separate things. All right, so my area. My area, in terms of y, is going to be equal to 2 pi RH. That's equal to 2 pi times y minus 1 times my negative y squared plus 6y minus 5. That's a fun one to distribute, right? Yeah, so I get a 2 pi times, let's do it, a y cubed, a negative y cubed actually. So that's y going into the negative y, plus 6y squared minus a 5y. That took care of my first term there. I just went into here and here and here, distributed that. Now I'm going to do my negative 1. I'm going to say plus a y squared minus a 6y plus a 5. Alrighty, isn't that beautiful? So I've got a 2 pi times combining like terms, a negative y cubed. I have this y squared in this one, so plus a 7y squared. I have these two y terms, minus an 11y, and plus 5. All right, my area. Doesn't it look beautiful? All right, so I'm going to take that. I'm going to go ahead and do my volume. I'm just going to write it out. So I have my volume is equal to the integral from c to d again of a of y dy. I'm going to put it down here so I can see things. So I have 2 pi, I bring it out front, times the integral of, I have my negative y cubed plus 7y squared minus an 11y plus a 5 with a dy on the end. Now take a look real quick. My limits of integration, they need to be in terms of y, because I have a dy, all my terms are y. My limits of integration better equal y values. So let's go back up to our picture. I'm looking at just that green shaded part. My lowest y value is 1. My biggest y value is 5, right? So from right here to right here. And so I'm going to put my limits of integration from 1 to 5, all right? From there, all you got to do is integrate, much like that last problem. You're just going to integrate each term separately and then sub in upper limit minus lower limit, and you can find your integral, all right? So if you have any questions, let me know. You heard a little meow there. My cat's helping me out today. Hopefully this helps and you get a feel for what we're looking at and why we picked cylindrical cells on this problem. But I wanted you to see, again, that shifted axis of rotation if you wanted to see one more shifted axis. All right. I hope you have a great day, and I'll be seeing you soon. Let me know if you have any questions.